In this problem, you've been asked for the area of region R. You should be thinking, I need a height times a thickness. The height is upper minus lower. Our upper curve is the line, 2x. The lower curve is the quadratic, x squared. My limits, my first rectangle would be 0, and I would track over to 2. So 0 to 2, this is the answer. Final area is here. Second problem, squares run perpendicular to the y-axis. Here's a series of squares. Each square will have dimension x on the right minus x on the left. That will be the base, and the height is the same as the base because they're both squares. So your volume will be the integral x on the right minus x on the left dy, because we're slicing this way. The thickness of each one of these rectangles or squares is dy. That means we're going to go from 0 now up to 4 because we're tracking this way across the figure. And now I just have to figure out how far is x right and x left. The curve on the right is y equals x squared. But since we need this solved for x equals, I'll take the square root of both sides and get x equals square root of y. That means I have this term figured out. Similarly, coming from left to right, the distance to the inside curve is y equals 2x. Solving for x, x equals y over 2. That means I'm subtracting y over 2. So this is the base of my rectangle. To find an area, I'd have to square that, because area is base times base, or base squared. So now I have my integral, square root of y minus y over 2. Again, this is all a base. That integrated from 0 to 4. Squaring to find area. dy is my thickness. Notice my y's all match in the integral. Your practice problem, your corrections problem, same thing. Do part A and B. For this second figure, two curves, y equals 4 minus x squared, and y equals 4 minus 2x.